Today we are going to look at our third way that we can solve systems. So we've talked about how we can solve systems by graphing. We've talked about how we can solve systems by substitution. Our final method that we are going to look at is solving systems by elimination. And before we even really get too far into solving systems by elimination, I want to talk about an important concept with subtraction and negatives that's going to come into play. So we've talked about already this trimester how subtracting and a negative are the same thing. It all just depends on the context of how we see it in a problem. Okay, so when we are talking about subtracting multiple things, so maybe I have 4 minus 2x plus 8 equals something, right? We've looked at this in an equation, right? We've talked about the fact that this is really a -1 sitting here. And we can really take this -1 and we can distribute it to everything inside those parentheses. Okay, and so this becomes a -2x and a -8. Or a -2x and a -8, right? We can read it either way. That same concept is going to apply today. And I think the key here to understand is that when we distribute a negative, we're really just changing the sign of the stuff after it. Okay, so we want to just pull from that prior knowledge that we have and be able to apply that into elimination today. So let's say we are given a system that says x plus 3y equals 14 and 2x minus 3y equals -8. Now we could solve this system by substitution. We've talked about how we could solve this top one for x and use substitution. Okay, but elimination is going to allow us to work around that process and not have to solve something for x or y. So when we are solving with elimination, we're going to have this nice, neat, stacked idea going on here, right? Where my x's are lined up, my y's are lined up, and my constants are lined up. And when we are in that format, the first thing that we want to look for is we want to look for an x or y that has a matching coefficient. Okay, so we want to find an x or a y with a matching number in front, right? The number in front is called a coefficient. Now, right now, we're not going to worry about if it's positive or if it's negative. We just want to see a matching coefficient in front. Okay, so this top x has a 1 in front and this one has a 2 in front. Those are not matching. Okay, but this top y has a 3 and this bottom y has a -3. Those are matching, right? So I'm going to ignore the positive and negative. I have a 3 and a 3. That's the only thing I'm going to focus on. So these are what match right now. Once we decide where we have a matching one, our next step is then going to be to decide if they have the same sign or if they have the opposite sign. Okay, so if they have the same sign, we are going to subtract. If they have opposite signs, we are going to add. Okay, and here is why. This is called elimination because our goal is to eliminate or get rid of a variable. So if I decide I want to get rid of these y's, okay, numbers that have the same sign, if we subtract them, they add up to 0. Or subtract to 0, right? If numbers have the opposite sign, if we add them, then they add up to 0. So this is a +3 and a -3. So we are going to want to add. Now, the key here is that we can't just add that one individual variable. We have to add the entire equations together. So this is going to be like multi-digit addition. And we're sort of going to add straight down in each column. Okay, so x plus 2x, which is the same thing as 1x plus 2x, gives us 3x. A positive 3y plus a negative 3y is 0, right? Those eliminate, they go away. So there's no y left. 14 plus negative 8. Now, remember, 14 plus negative 8 is really like 14 minus 8, but either way you think about it is fine, is 6. And so now we have something that just says 3x equals 6. And this is something I hope we know how to solve. Okay, so we can just divide these both by 6, and we get x equals 2. Now, we have said this multiple times, right? At this point, we know our x value, but we're not done because the system has an x and a y value. In elimination, it's easier to find the first number. It's going to be a little bit more work to find the second number, but the concept is still the same. We want to take this x and we want to plug it back into one of these equations. We don't have one that's solved. We don't have one that's underlined, so we don't kind of have that nice, neat location to plug it into. So we're just going to have to pick one of the equations. You can decide because it has your favorite number, because it's smaller numbers, whatever. I'm going to pick this top one, and I'm going to plug this in for x. So now instead of this saying x plus 3y, it will say 2 plus 3y, right? I substituted that 2 in for x equals 14. And again, now we just have a new equation that we should hopefully be able to solve. So I'm going to move a positive 2 by subtracting 2. I'm going to do multiplication with division. So our y value equals 4, and our final answer is 2, 4, or x equals 2 and y equals 4. Okay, so let's take a look at another example here. Let's say we have 2x plus 2y equals 4, and 3x plus 2y equals 7. So the first thing that we want to do is we want to find where we see a matching coefficient. The x has a 2 and a 3, that does not match. The y has a 2 and a 2, so that matches. It could be the x or the y. It just so happened on both of those two right now that it's the y. Okay. We are then going to decide if they have the same sign or if they have the opposite sign. Okay, well, this is a positive 2y and a positive 2y. Those are the same sign, so we are going to want to subtract. Now, yes, you can subtract just by doing normal subtraction, but I'm telling you, as someone who's been teaching this for a long time, especially when negatives start to show up and we have some other math going on because we're not fully done with elimination today, we are going to really try and avoid that subtraction. And it's going to be a lot easier for us to distribute the -1 and to turn this into addition. Okay, so to do that, it's just like we did on this original example where we're distributing a -1, and we're going to distribute it to everything that's after that subtraction. Okay, so think about this as if it's a -1 and it's going to everything after the subtraction. So this positive 3 becomes a -3. The positive 2 becomes a -2. And the positive 7 becomes a -7. And then, right, I'm adding the opposite. So I changed this to addition. I distributed my -1. And now I can just add straight down. And so now I can just take 2x plus -3x is a -1x. My y's are going to cancel out. 4 and a -7 gives me a -3. And this is something I know how to solve. So I will have x equals 3. But again, I'm not done yet. I still need to plug that in to find my y value. So I'm going to plug it back into the top one, again, just because that's the one I'm picking. Okay, it doesn't necessarily matter. So instead of saying 2 times x, now I'm going to say 2 times 3, because I'm substituting that 3 in for x, plus 2y equals 4, and this is something I now need to solve. Okay, I'm positive 6 by subtracting. And I will get y equals -1. So my x value is 3, and my y value is -1. Okay, one final example here that we are going to look at. Let's say we have 3x minus 2y equals negative 2, and 3x plus y equals 10. Okay, so again, our first goal is to look and see where we have that matching coefficient. The x has a 3 and a 3. Oh, right off the bat, these are matching. Okay, so that's where we're going to want to focus. And then we are going to decide if they have the same sign or if they have opposite signs. Well, it's a positive 3 and a positive 3. So if those are both positives, we are going to want to subtract, right? Same sign, subtract. Except we don't really want to subtract. We really want to add the opposite. We really want to add and then distribute that negative 1 through. So a positive 3 becomes a negative 3. A positive y becomes a negative y. A positive 10 becomes a negative 10. Now, keep in mind, if this was a negative 10 and I had to change the sign, it would become a positive 10. And now I'm just going to add straight down. A 3x plus a negative 3x just cancels out. A negative 2y plus another negative 1y gives me a negative 3y. A negative 2 and a negative 10 give me a negative 12. This is something I can solve. Okay, so now I have y equals 4, so that's the second number in my ordered pair. Okay, and then I can plug back in to find my x value. Now, you can plug back into this equation. You could plug back into the equation where you distributed the negative or the original equation before you distributed the negative. So I'm actually going to plug back into this equation that said 3x plus y equals 10 before I distributed the negative 1. I don't want to deal with the subtraction and the negatives, so I'm just going to plug it in right here and say 3x plus 4 equals 10. And I will get x equals 2. So my final answer is 2, 4, or x equals 2, and y equals 4.